Clipper has been the excitement in the back of my mind recently, so I'd like to take a moment to speak about it. If you've been keeping up with the news, you'll likely have seen that the Europa Clipper has launched from the Kennedy Space Center. The probe launched at precisely 12:06 p.m. Eastern Time, October 14th this year, from Launch Complex 39A. Clipper launched from a SpaceX Falcon Heavy rocket, expending all 3 lower stage boosters to give the probe as much delta V as possible. Delta stands for a change in something, and V is the variable for that something. That something being velocity. Essentially, delta V is the maximum change in velocity that the rocket can give itself, usually in meters per second or kilometers per second format. This not-so-small probe has radar, spectrometers, multiple cameras, a topographical imager, 2 Langmuir probes, 2 gravity science antennas, a magnetometer, and much more that I'll go over, all of which are to perform its task of researching Jupiter's most interesting moon. Clipper is the largest space probe that NASA has ever built, fully fueled at 6,065 kilograms, with a dry weight of 3,241 kilograms, which means just over 45% of Clipper's mass is propellant for its 24 engines to maneuver and propel itself with a maximum force of 220 newtons. The probe only uses up to 8 engines at a time, however, for redundancy purposes, having bow and aft-facing engines just in case of engine failure becoming critical on one side. The solar array alone is roughly 92 feet across, making it easily the biggest asset that Clipper has, giving the probe 600 watts of charging power. This is the largest solar array that NASA has ever had to construct. In second place is the 28-foot magnetometer boom, which will be used in tandem with the plasma imager called PIMS to measure the magnetosphere that Europa has, so we can confirm whether Europa actually has oceans. It can also measure the salinity of Europa's oceans because more ions equals stronger magnetosphere. Reason, which is an interesting name for Europa's radar system, will measure everything from elevation, composition, and the structure of Europa, hopefully giving us an answer to the question many people have been asking. Is there life on Europa? Even though that's not the technical purpose of the mission, it would definitely be an interesting find. There are multiple cameras on board Clipper: a thermal emissions imager, an infrared spectrometer, a wide-angle and narrow-angle camera, and an ultraviolet spectrograph, all of which will be used to study Europa's composition, maybe even finding new geographical concepts we've never thought about. Clipper also has a mass spectrometer attached to its side, along with a surface dust analyzer, which will be able to measure the large plumes that we see coming off of Europa, the composition of gases surrounding the moon, and even measure how the Van Allen radiation affects the material that it collects. Finally, I'd like to talk about the vault plate that's been attached to Clipper. The most notable thing about it is, if you've ever worked with audio software, you'll immediately notice all of the waves that point inwards to the American Sign Language word for water. Each of those 103 sound bites contains a different language's version of the word water, in homage to how water is so necessary to our lives and in homage to Clipper's mission of searching for water. There are many other symbols on the plate, which I might even dedicate an entire video to, along with all of the other equipment on board. For the sake of statistics, like if you want to, comment to recommend to, and subscribe to get the best chance to get more of my content recommended to you. And I'll see you in a few days.